Hi everyone, today we are going to go over the study guide for our Chapter 8 test. If you are a remote learner, please remember that you are expected to take your test during your scheduled geometry period. As always, just send me an email if you have any questions. All right, so for numbers 1 through 4, we want to draw a sketch of the indicated figure, and we want to mark the defining features of the figure. Number 1 is a trapezoid. So here's our sketch of a trapezoid. The only defining features we really need to make here are those two arrows for the bases because we know that the bases are parallel. Number 2, a rhombus. Here's our sketch of a rhombus, and by definition, a rhombus has 4 congruent sides. So I drew a quadrilateral and then have my tick marks on each of the sides, just telling us that those sides are congruent. Number 3, we want to draw a kite. So here's our diagram of a kite. And just remember that the consecutive sides are congruent and they have one pair of opposite angles that are congruent. Number 4, a rectangle that is not a square. So by definition, we just need to make sure we have 4 right angles. And since this is not a square, I need to make sure that I don't have 4 congruent sides, so we know in a rectangle that the opposite sides are congruent. Number 5, the figure at the right is made of a square and an equilateral triangle. We want to find the measure of FIV. All right, so let's talk about what it means to be a square and an equilateral triangle. For a square, we know that all the sides are congruent. And we also know that all the angles are right angles. We also know that it's an equilateral triangle. An equilateral triangle means all 3 sides are congruent. So if this side is the same for our square, we also know that these sides are also congruent to the sides of my square. We also know, because this is an equilateral triangle, that the angles inside the triangle are all congruent. So that means that each of these angle measures are 60 degrees. So this is 60 degrees, as well as this angle and this angle. So for A, when it said to find the measure of FIV, FIV is this angle right here, which is made up of 90 and 60 degrees. So I just add those up, and I know that that is 150 degrees. Part B, if we know that VE is 6 inches, what's the perimeter of this entire figure here? All right, so VE is right here. This is 6. Well, we notice all the tick marks. So if this is 6, then this is 6, as well as this side, and this side. So perimeter just means adding up all the sides. So if I add these up, I end up getting that the perimeter is 30 inches. Number 7, TRAP below is an isosceles trapezoid with the measure of angle T equals to 74. Find the other measures. All right, so angle T is 74, which means this is 74. Now we know this is an isosceles trapezoid, so by definition, that means that these 2 legs are congruent. Well, we also know that in an isosceles trapezoid, the base angles are congruent. So T is 74, that means that angle P is also 74. So I'm going to put that here, 74. Now we need to figure out the measure of angle R and angle A. Now, since this is a quadrilateral, we know that these consecutive angles are supplementary, meaning that they add up to 180. So I know that 74 plus the measure of angle R is going to equal 180 degrees. If I subtract 74 from each side, the measure of angle R then is equal to 106. So this would be 106, If the measure of angle R is 106, we also know that the measure of angle A is also 106. Number 8, name the figure from its definition. Which quadrilateral has the definition that 4 congruent sides? Well, that would be a rhombus. For C, at least one pair of parallel sides. So at least one pair, so it means one or more. We actually have a bunch here. So the first one is a parallelogram. By definition, a parallelogram has 2 pairs of parallel sides. Now there are 3 special types of parallelograms. The 3 special types of parallelograms is a rhombus, a rectangle, and a square. Now there is one more quadrilateral that has 1 pair of parallel sides, and that is a trapezoid. Number 9, name a property that a square inherits from a rhombus. And there are 2 properties. One is that we have the 4 congruent sides, and our second one is that the diagonals are perpendicular bisectors of each other. 10, name the properties that a square inherits from a rectangle. And once again, there are 2 properties that the square inherits, and one is that it has 4 right angles, and number 2 is that the diagonals are congruent. 11, name a property that a rectangle inherits from a parallelogram. The first one is that the opposite angles are congruent. Number 2, that the opposite sides are congruent. And our third one is that the opposite sides, let's try that again, the opposite sides are parallel. Number 15, fill in the names of the quadrilateral in the hierarchy at the right. So this whole chapter is talking about quadrilaterals. Now, when we have our quadrilaterals, it's going to split up into 2 groups. The first group right here is a kite, and we see this figure here. And then over here we have a trapezoid. Okay, now with a trapezoid, the trapezoid is going to split up into 2 different types. We have a parallelogram, because technically a trapezoid or a parallelogram is a trapezoid. And then we also know that there is a special type of trapezoid called an isosceles trapezoid. Now if we go back to our parallelogram, we know that there are 3 different types of parallelograms, but the 2 main ones split up is a rhombus and a rectangle. And then our very special quadrilateral that is all of these types of quadrilaterals put together is our square. So now that we have our hierarchy drawn out and written out, let's look at these questions and see if they are true or false. So every rhombus is a kite. That is true. So by definition, a kite has that the consecutive sides are congruent, which is also true in a rhombus. This side is congruent to this side, and this side is congruent to this side. And we also know that in a kite that we has at least 1 pair of opposite angles that are congruent, and this is also true in a rhombus. 17, every trapezoid is isosceles. That is false. We know that the definition of an isosceles trapezoid is just when the legs and the base angles are congruent. And then 18, every parallelogram is also a square. That is false, because we know that that there are different types of parallelograms, a rhombus and a rectangle. And by definition, a square is a rhombus, but a rhombus is not a square. Same thing with a rectangle. We know that a square is considered a rectangle by definition, but A rectangle is not a square. In 1 and 2, mark all the congruent angles and segments. So our first example here, we have a kite. So we know by definition that the consecutive segments are congruent. So this side and this side are the same length. And we also know that this side and this side are the same length. We have our diagonals here, and we know that this diagonal is bisected or cut in half by the longer diagonal. And the last thing we know is that angle Q is the same measure as angle S. For number 2, we have a rhombus, ABCD. So definition of a rhombus is 4 congruent sides. And we have our diagonals. We know that the diagonals of a rhombus bisect each other. So 1, 2, these segments are congruent, and these segments are congruent. And the last thing we know about this rhombus here is that the opposite angles are congruent. So angle B is congruent to angle D, and angle C is congruent to angle A. Our next problem here, refer to kite MGZX at the right, where the measure of angle 2 is 46 and the measure of GZX is 64. Find the given angle measures. All right, so I'm going to pause the video and fill in what we know. So I marked what they told us, that the measure of angle 2 is 46 and that the measure of angle GZX is 64. So let's start with A, the measure of angle 7. Well, the measure of angle 7 is right here. And we know that the diagonals of this diagonal of a kite is going to bisect these two angles, angle M and angle Z, in half. So if angle 2 is 46, that means that angle 7 is also 46. So let's focus then on angle 5 and 6. If we know that that large angle is 64, then if I just divide 64 in 2, I will then get the measure of angle 5 and angle 6. So 64 divided by 2 is 32. So angle 5 is equal to 32 degrees, and angle 6 is equal to 32 degrees. Since we have a kite and we have our diagonals, we also know that the diagonals in a kite, they are perpendicular to each other. So that means that angle 1 then is 90 degrees. So lastly, I need to figure out what is the measure of angle 4 and angle 3. Well, if I look closely, I notice 2 right triangles. And I'll kind of sketch this out. I have a triangle where this is 46, and I need to figure out the measure of angle 3. So if I need to figure out the measure of angle 3, I know the sum of my triangle is 180. So the measure of angle 3 plus 40 degrees plus 90 is equal to 180, which means that the measure of angle 3 is going to equal 44. So here we have 44. I'm going to do the same thing to figure out the measure of angle 4. So here's my right triangle. I know that the measure of angle 5 was 32 degrees. I need to solve for the measure of angle 4. So I know that the measure of angle 4 plus 32 plus 90 is equal to 180, which means that the measure of angle 4 is equal to 58. And 58. And we're done. In rhombus UMNJ, we know that UH is equal to 14. And the measure of angle UMH is 31. For number A, or for letter A, give as many segment lengths as possible. Well, the only length right now that we know is UH, and UH is part of the diagonal. We know that in a rhombus, our diagonals bisect each other, which means that they cut each other in half. So if UH is 14, that means that HN is also 14. Now with the definition of a rhombus, our diagonals are not congruent, which means I don't know anything about JH or HM or that long diagonal JM. So the only diagonal I can focus on is the one I have written down. All right, so next let's figure out our sides here. By definition, a rhombus has 4 congruent sides. So let's focus on that yellow right triangle that I just drew. So I know that this is 31. Definition of a rhombus is that the diagonals are perpendicular bisectors of each other. So this angle here has to be 90. I know the height of my right triangle is 14. I need to figure out x. So this is a right triangle where the Pythagorean theorem doesn't work, but instead we can use our good old friend trig to figure out what is the length of x. So to solve for x, I'm going to use sine. So I know that the sine of 31 is equal to 14 over x. So if we do our math, we end up getting that x is equal to approximately, we'll say 27.2. So that means that segment UM, segment MN, segment NJ, segment UJ they're all approximately 27.2. Now, this will not be on the test as a normal question, but the bonus has to deal with trig. So that's why I threw this problem in here. The rest of the answers here, I'm just going to write down. It's nothing that you're going to be tested over, but like I said, it could help you with the bonus. So for B, give as many angle measures as possible. And if you look at our rhombus here, we know that the measure of angle MH is equal to 31, the measure of angle UJH is equal to 31, and the measure of angle NJH is also equal to 30. Remember that if we have a triangle, our angles add up to 180 degrees. So to figure out that angle, we end up getting 59. So the measure of angle MUH is equal to 59. The measure of angle JUH is equal to 59. And the measure of angle NHM is equal to 59. And lastly, I'm not going to write these down, but remember all of these angles here are 90 degrees because the diagonals bisect each other. So I'm going to be done with this problem, number 4, and we're going to move on to the next problem. Segment RS and segment JK are the bases of our trapezoid JKSR. If the measure of angle K is 133 and the measure of angle R is equal to 61, we want to figure out the measure of angle J and the measure of angle S. So first off, we just know that this is a trapezoid, not an isosceles trapezoid. So in looking at the pictures, we can kind of see that those legs are not congruent. So let's plug in what we know. So we know angle K and we know angle R. So we need to figure out J and S. So for J here, I'll call this X, and for S, I'm going to call this Y. All right, so we know that this is a quadrilateral, which means that these two angles, when we add them up, it equals 180. So if I'm trying to find X, I know that X plus 61 is going to give me 180. Subtract 61 from each side. I end up getting that angle J is equal to 119 degrees. I need to do the same thing for S, and we'll call that Y. So I know that Y plus 133 is equal to 180. So then y is 47. Next, we're going to find the mid-segment of this trapezoid, and we know that that is right here. The equation for the mid-segment is just to add up the bases, divide that number by 2. So in this case, our base is 12, and the second base is 36. Divide that by 2. That will give us the value of x. Plug that in your calculator. 24 is equal to x. In rectangle EFGH, the measure of angle F is equal to 2 times the quantity 6t plus 3. We want to solve for t. Well, our keyword here is rectangle. What do we know about the angles in a rectangle? Well, we know that they're all equal to 90. So it doesn't matter which one we're looking at. We know that it's equal to 90. So that means that 90 is equal to 2 times the quantity 6t plus 3. Let's distribute that 2 inside the parentheses. So we end up getting that 90 is equal to 12t plus 6. And so we end up getting that 7 is equal to t. All right. And our last problem for the study guide, in UVWX, we know that the measure of angle U is equal to 5x plus 13. The measure of angle X is equal to 129 minus 3x. The measure of angle W is equal to 4x minus x. And the measure of angle V is equal to 8x minus 17. Find the measure of each angle in this quadrilateral. Well, we don't really know the specifics, exactly what each angle equals to. But what we do know is that this is a quadrilateral and that it's a trapezoid. They have 4 sides. So if you think back to the beginning of chapter 8, if I wanted to figure out what is the measure of the interior angle of this sum, I would use my n minus 2 times 180. Well, we already know what that is equal to. We know that the sum is 360 degrees for a 4-sided quadrilateral. So I'm going to take my equations, so the 5x plus 13, plus my second equation for x, measure of angle x, which is 129 minus 3x, plus the equation for angle w, which is 64 minus x, plus the measure of angle v, the equation, which is 8x minus 17. I know that all of those added together, those angle measures have to equal 360. So let's combine your like terms. So here's an x, here's an x, here's an x, and here's an x. So 5x minus 3x minus 1x plus 8x, that's going to give us 9x. Now I need to do 13 plus 129 plus 64 minus 17. When I add those up, I get 189 is equal to 360. And you solve for x, we end up getting that x is equal to 19. But I'm not done because it didn't ask me to solve for x. It asked me what are those angle measures. So I need to plug x back into all of my equations. So when I plug x into my equation for u, I get that that measure is 108. When I plug x into the equation for, I'll actually do this x, I end up getting that this is 72. When I plug x in for the equation here for w, I end up getting that w is 45. And finally, when I plug in x for the measure of angle v, I end up getting that angle v is 135.